Hey guys, right now we're going to be looking at inverse operations. And so before we start that, I want to kind of talk to you about inverse operations and what that really means. So now, let's think about the word inverse. So if I were to put my shirt inverse, that means it would be inside out, right? And so it's kind of like opposite. You have to think about the word as opposite. And when we think about opposite in math, I always think about a couple of things. We have a addition, subtraction, multiplication, and division. And these can be seen in different ways in math, okay? Especially multiplication. So multiplication can be seen like this. So for example, if I see 2x, what are the 2 and x doing? They're multiplying. But Mr. Smart, I don't see a multiplication symbol in between them. Right? Well, that's telling you that there's 2 times the x amount, right? So you have to see this as multiplying. What about the letters, the 2 and the variable t? What are the 2 and t doing? They're multiplying, that's right. What about the 4 and the letter v? What are the 4 and the v doing? They're also multiplying. Now what if you see this? 3 times the letter t. That little symbol means times, so just a heads up if you ever see that, okay? So remember, multiplication may not always show itself, but just know that it is there, okay? Now these will always show, but division may look a little different. So you might see this, let's go x over 3. Okay, you have to say that x divided by 3. So x divided by 3, oh, okay, so that it can look that way too, right? So just certain possibilities. What about letter t over 4? It's t, divide that by 4, right? So just be aware of those before you start. So think about inverse, so opposites. The opposite of adding is what? Yeah, subtracting. Or you could think the opposite of a positive is a negative. What about the opposite of subtracting? Just like up here, the opposite is plus. So the opposite of a negative is a positive. Now look at this multiplication symbol. The opposite of that is division. Good job. And the opposite of division is multiplication. And the reason why we're talking about this is because you're going to run into scenarios in math that might look like this. So let's say we have 5x plus 2 equals 12. Okay, you're going to run into the situation quite a bit. Now we have to think to ourselves, okay, I have a 5x plus a 2 equals 12. Pause. What are the 5 and x doing? They're multiplying. And that 2, what's it doing with the x? It's being added. Okay, good. So I got to think opposites. I got to divide at some point because this is multiplying. And I got to subtract because that's adding. Okay, so I'm on the right track. But which one do I do first? That's the question. Now, we're going to go back to the word inverse, okay? And we always have our order of operations. But when you see inverse operations, you got to think about PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction, right? Please excuse my dear Aunt Sally. What inverse means opposite, means inside out, means backwards, right? So what is this backwards? Oh, it's SADMEP. It's basically PEMDAS written backwards, right? And so you have to go in this order in order to do inverse operations. So instead of, usually multiplying, dividing first, you have to subtract and add first. And so you got to ask yourself, what's being added in this equation, right? So I'm going to build my wall first, just like that, always at the equal sign, and ask yourself, what is being added right here? Okay, what's being added? Is the 5 and x, are those adding? No, we talked about it up here, right? Look, this is multiplication, and these two are multiplication. So the 5 and x, even though there's no symbol in between, those are multiplying. And that's right here in the middle. I don't multiply or divide yet, okay? So now look at this plus 2. This is addition. I don't see any subtracting, so I guess we got to add first, right? Because we got to go inverse operations. So adding is first. Now inverse means opposite. What is the opposite of plus 2 right there? The opposite of plus 2 is to subtract 2, just like that. Now the rule is, if you do it to one side of the wall, you always have to do it to the other. So that's the rule of inverse. You have to do it to both sides of the wall. And the reason why I'm subtracting 2 for him is because, kind of think about like terms, right? These guys are like terms right there. So I can subtract them from each other. Okay? A positive 2 and negative 2 make a 0. So anything plus 0 is still the same number. So I can just cross those out. I'm done with those. Okay? Now I got to look over here at my 12 minus 2. So 12 minus 2, 12 positives, 2 negatives. The positives win by 10. Equal sign always goes right here. And did the 5x ever get touched or changed? It didn't. And this doesn't exist anymore, so I'm just going to move them right here. Boom. Now we're left with 5x equals 10. Okay. So now I have to think about this. The 5 and x, what are they doing? And there's no more subtracting or addition anymore, so I can just focus on this. The 5 and x are multiplying. The inverse operation of multiplying is to divide. Okay, so the opposite of multiplying by 5 is to divide by 5. So I drew a line and put a 5 over here. But when you do inverse operations, if you do it to the left side, you also have to do it to the right. So divide this by 5. You see how I drew a line, put a 5 right there? Do the same thing. Draw a line, put a 5 right there. Okay. Now if I divide that by 5, right, makes 1. And 1 times x is just 1x, so I don't need to put a 1 there. I'll just put the letter x. Okay. Oops, sorry, my camera turned off again. I'm back, sorry. Now, look at this right here. The 5s, I'm just going to cross those out. They no longer exist, really. And now this is just basic division. In a calculator, 10 divide that by 5 equals 2. And this is where I put my 2. And now you got to ask yourself, is there any more things multiplying to x? Is there any more things being added to x? No, there's not. So guess what? X equals 2. And that's how you do inverse operations, right? Now, here's a practice problem I want you to try on your own, and we'll check this together. Okay? Let's go 3x minus 2 equals 19. Go ahead and try that one on your own. You can hit the pause button right now, and I'll wait for you to be done. Okay. Hopefully you hit on pause by now. If not, pause it. If you're already done with your question, let's get going. Okay. So think about SADPIM. What's first? The S, right? Is there anything subtracting over here with the x? Oh, there is. What's being subtracted from the x? It's a negative 2. Okay. So think opposite. The opposite of negative 2 is a positive 2. Okay. So I got to add 2 to the left side, but don't forget the wall. There's also a right side. Oh, okay. So I'm going to add it to both sides right there. So I'm adding the 2 and 19 because they're like terms. Remember, they're combining like terms? I can add these together. Now, a negative 2 and a positive 2? That equals 0. So do I need them there? No, anything plus 0 is the same, so let's cross them out. And 19 plus 2, a positive and a positive make more positives, right? So 19 plus 2 is going to be equal to 21, just like that. Did this guy change? You got to ask yourself. No, he didn't, so I just bring him down. And he's on the left side of the equal sign. And sometimes I see kids make the mistake of writing it on the same side over here by accident. So just make sure you keep them on this side of the wall and you'll be okay. And now I get 3x equals 21. Ask yourself, 3 and x, what are they doing? Are they adding, subtracting, multiplying, dividing, exponents, parentheses? I gotta know. Look up here. Oh, they're multiplying. Okay, since they're multiplying, I have to divide. Okay, so when we divide this, it's 3 times x. The opposite is divide by 3. And what happens to the 3's? Well, 3 divided that by 3 is 1x, and I don't need a 1 in front of my x because I can just draw 1x. Okay? And don't forget the equal sign. 21 is my answer, right? No, it's not. Why not? Think about why it's not the answer. What did I forget to do? Up here, I divided both sides by 5, but did I divide on both sides? Oh, I didn't. So make sure you divide by both sides. See, if you're a student, catch yourself sometimes, right? Just like that, I can make that mistake too. 21, divide that by 3 in a calculator, is x equals 7. And that would be your answer right there. Okay? So good job if you got that right. If not, really look at what you did wrong and restart at that point and acknowledge what you did wrong. So that way you can always try to avoid that mistake in the future. So now I'm going to make it a little bit more difficult. I'm going to do some negatives, okay, and a division problem. So let's do this. Let's do a negative 2 plus, let's go the letter T this time because I need to switch it up, over 4 equals 30. Let's go 30. Just like that, okay? So think opposites. I think SADMAP. What goes first? Should I divide, multiply first? No, that's in the middle. Is there anything being subtracted or added? So this one might be a little bit more tricky because I put the negative 2 right here. Okay? So the opposite of negative 2 is what, guys? Is a positive 2. So I need to add 2 to not only the left side, but the right side. You always do to both of that little wall. So there's being added right there, and I'm going to add them over here. So negative 2 and a positive 2, that's going to do what? It's going to cancel out because that's 0. And now I'm going to put my equal sign. Don't forget your equal sign. 30 plus 2 gives you 32. Okay, we're on the right track. And did this change? Nope. And that's a letter T over 4. Why didn't I move the positive sign here? Well, because I don't need to. It's just not there. You don't need any positive symbols. There's nothing being added anymore, right? We have the T almost by itself. So think about this in your head, right? Oh man, I gotta think what the T and 4 are doing. And that line, what does it mean? That can mean division. Oh, okay. So they're dividing. Be a logical thinker. The opposite of division is to multiply. Okay. So I had to multiply this by 4. Okay. But if you do it to one side, you also have to do it to the other. Just like that. Now, they always say this. Put a 1 underneath, and these can cross each other's out, right? And then T over 1, you can just put the letter T. So you see how those cancel each other out right there? Well, they don't cancel each other out technically, but it's close. So you get the letter T by itself. So that's why you multiply. You're getting the letter T by itself. Now, let's look at this. I'm going to put my calculator right here. Okay, we get 32 times 4, and that gives us a 128. So the letter T is equal to 128. Just like that. Okay? Okay. Now let's try one more. This time, go ahead and pause the video when I'm done writing this question and try it by yourself. Okay, so not yet. Let's go. I'm going to try to make it a little tougher. Let's go negative 5 plus 10x equals a negative 55. Okay, so remember, you got to know some positive and negative rules now. Okay, so go ahead and pause that video, and when you finish, unpause it and we'll check it together. Okay. Okay, hopefully you unpaused it by now, and let's look right here. So remember, inverse means opposite. SADMAP. Let's see, the 10 and x are multiplying. Is that first? Like a SADMAP, subtracting, adding. No, that's multiplying. That's not first. Negative 5. Okay, that's being subtracted, right? So that's a negative 5. I can get rid of him first. The opposite of a negative 5 is a positive 5. Just like that. Now if you do it to one side, do it to the other. Okay. These get canceled out. They no longer exist. That is equal to 0. So I'm going to put my equal sign right here. And this is, ooh, remember, you guys see how this is a negative and positives? This is why it's important to remember your combining like term rules and the positive and negative rules. Yeah, 55 negatives and 5 positives, right? Think about that. Do they like each other? They don't. But there's a lot more negatives, so who's going to win that fight? I think the negatives will win, so you put a negative symbol. And it's gonna cost them 5 guys, so 55 minus 5 is going to be 50, so it'll be a negative 50. Okay? So remember, the symbols are different, you subtract them. And the bigger, well, it's not the bigger, but the more, the symbol with the more will win. And this didn't change, so I got to make sure I put them over here. Don't put them over here, keep them on the left side of the equal sign. Did you do all this correctly? If so, good job. If not, check what you did wrong, okay? Take that moment. Say, oh, I did something wrong. Let's see. So now, hello, testing 1, 2. I'm really hoping my mic's on. Okay, I think it turned off for a little bit, so hopefully it's back on. Okay, let's look at this. 10x equals a negative 50, right? So now, ask yourself, the 10 and x, what are they doing? Oh, it looks like they're dividing. So let's divide both sides by 10, because the opposite of multiplication is division. Now, 10 divided that by 10 turns into 1, but I don't need those there because I can just write 1x right here. And now you got to know the multiplication rules. A negative, divide that by a positive is the same rules as multiplication. So a negative and a positive make a negative. So your answer, 50 divided that by 10, is a negative 5. So there is your answer right there. So x is equal to a negative 5. Hopefully this helped you out. If you have any questions, go ahead and go to the comment section, and maybe one day I'll answer you if I see it. Thank you.